All right, SAT 22 for week 16. We've got a right triangle has legs with lengths of 24 centimeters and 21 centimeters. If the length of this triangle's hypotenuse in centimeters can be written in the form 3 square root d, where d is an integer, what is the value of d? So it looks like they have computed the value of the hypotenuse and then put it in simplest radical form, and we had to type in our answer. How did we do? Let's take a look. You can see from this bar graph here that most of us answered 113, which is in fact the correct answer. Nothing even comes close. And that was nearly 80% of us with the correct answer. And we said that it was roughly medium, skewed a little bit towards the easier side. So let's take a look at the actual solution here. So I'm going to go ahead and sketch a picture, as I usually do. We've got a right triangle. Perfect. We have a 24 for one leg, and we have a 21 for the other leg, and we can call the hypotenuse c. So we'd use the Pythagorean theorem on it, of course. So c squared is equal to a squared plus b squared. I don't have anything to put in for c, so I'll leave it. My a, doesn't really matter which one is which as long as they are both legs, so I'll say 21 squared plus 24 squared. And it's probably at this point that you'd pull out that calculator and go 21 squared. I think it's 441. We'll double check that in a second. And then 24 squared here, I think, is somewhere around 576. Here, let's fact check that with the calculator, shall we? Here, let's side by side so I can make sure I'm getting these numbers right. Boop, boop. Okay, so I want a 21 squared, 441. Yes. Zoom in there. And then, let's see, hit enter on that, and then a 24 squared, 5. Oh, yes. All right, so I'll just go ahead and add that to the 21 squared, and I get this c squared is equal to 1017. I'm curious to know, did anybody answer 1017 here? Let's see what the internet says. Let's see. It looks like some of them did. It's right there, 1017. Okay, go back to our solution. Now, last step, Pythagorean theorem is always to take the square root. So c is equal to the square root of 1017. And then, well, we got to make it look like this. So making it look like 3 times the square root of d means that I'm going to have to simplify this radical. I have to put it in simplest radical form. So simplest radical form means that if there's a number inside of the square root, which is called the radicand, that's a perfect square, you got to pull the thing out. So what you do is you just kind of factor this thing. So whenever you go to factor it, I'm looking for anything that goes into 1117. So when I'm looking at this, if I add up the digits, I get a 7 plus 1 more, that's 9, which is divisible by 3, which means 3 goes into it. So here I'll just divide by 3. So 3, and then let's see, 3 goes into 10 3 times with 1 left over, and it goes into 11 also 3 times, this time with 2 left over. That's 27 divided by 3 is 9. 3, 3, 9. I wonder if anybody answered that answer choice. Here, let's take a look. 339. Oh, sure did. Actually, a few more people chose 339 than 1017. However, I can't do anything with either one of these numbers because neither one of them is a perfect square. Also, like, I need a pair of one of these numbers for one of them to come out of that square root. Okay, so I'm going to keep going. 3's prime, it's good. However, 339 is also divisible by 3. I just see nothing but multiples of 3 here. So I'm going to take 3, divide it into 3, I get 1, divide it into 3 again, I get another 1, divide it into 9, I get a 3. And that was the correct answer. The reason why it's the correct answer is because now with this factor tree, I can see that this thing is written as the square root of 3 squared times the square root of 113, and the square root of 3 squared is just 3 times the square root of 113. So here is then our value of d. D equals 113. Now, I honestly, I probably wouldn't have done it exactly like that. I think that there's a somewhat faster way to do this, and that is to assume that the hypotenuse is in fact 3 square root of d. However, there is an opportunity to make sort of an algebraic mistake if you're not careful. So I'm going to sort of repeat the process here, except for use 3 square roots of d in the place of my c. So it's 3 square root d. It's got to get squared, the whole thing, and then it's still equal to 21 squared plus 24 squared. Well, we know that the right-hand side is 1017. We already did that work. On the left side over here, whenever I square 3 square root of d, I have to, well, it's basically multiply times itself. So 3 square root of d times 3 square root of d. And whenever you multiply the 3's together, you get 9. And whenever you multiply square root of d times the square root of d, that's the square root of d squared, which is d. It's technically the absolute value of d, but since we're dealing with geometric lengths, it's a positive number, so it's just d. All right, and then finally, to get d, you just divide by 9. So d is equal to whatever 1017 divided by 9 is, which just happens to be 113. So check. I think that one's just slightly faster, and you didn't even have to worry about trying to factor your number of the factor tree in order to reduce your square root.